I'm going to be going through some base graphs for transformation. So base graphs are essentially our starting points, and then we're going to move them around. So for example, we have some sort of base graph, and it looks, you know, like something like this. And then we're going to move it, and it's going to look, maybe it's been moved up, and it's been stretched or something, so it looks something like, or some, and left and right. It's been transformed in some way. But in order to be able to do transformations, we have to know what our starting graphs look like. They're not going to be weird shapes like that. They're going to be some regular ones. So I have a graph here to help me out. I'm going to be doing it on some grids. So you could either watch this or do it yourself. So let's do this one first. So this is going to be a quadratic, and I'm going to be graphing y equals x squared. And the way I graph that is I need to fill in the table of values. I'm going to go through this relatively quickly. Minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, 0, 1 squared is 1, 4, and 9. So that's my table of values. I'm going to plot these points. So minus 3 is 9, minus 2 is 4, minus 1 is 1. It's hard to see that line because it doesn't actually exist. Something happened to it. 1, 4, and 9. And if we look at it, and those are going to be the points that we're going to transform if we need to, but for now we're going to say that also that's our, and we have a name for this, it's a parabola. Yay! Okay, a cubic. So minus 3 cubed is negative 27. Oh, actually, I changed the scale. It's hard to see probably, but that's 1020. So that's actually going to fit. Minus 2 cubed is going to be minus 2 times minus 10. 2 times minus 2 is negative 8. Negative 1, 0, 1, 8, 27. So 1 and 1, that's 5. That's going to be somewhere over there. 2 and 8 will be kind of over there. 3 and 27 will be kind of over there. Negative 1 and negative 1. Negative 2 and negative 8. And negative 3 and negative 27. And so it looks like the shape of a cubic is something like that. So that's a parabola, but with that side. Flip down. So parabola, cubic. A root graph. Square root of negative 1 is, we'll start over here. The square root of 9 is 3. The square root of 4 is 2. The square root of 2 is big mess. It's like 1.4, I think it is. Root 2 equals 1.4. Roughly. Square root of 1 is 1. Square root of 0 is 0. And the square root of negative 1 is error. You can't square root of a negative number. All right, so it's undefined. It's actually imaginary. So I'm going to write a name, but really it's something called imaginary. Either way, we're not going to be able to graph that. So what do we know? We know that at 0, it's 0. At 1, it's 1. At 2, we'll figure that out in a second. At 4, we're at 2. At 9, we're at 3. At 2, we're at 1.4 or something like that. And this graph looks like this. So it does continue out this way, but over here, once we get into the negatives, it actually stops. So the graph starts there and does not continue, and then it keeps on going in that way. That's our root x graph. Reciprocal graph. Y equals 1 over x. So we'll start over here. So 1 over 3 is a third. That's a half. 1 over 1 is 1. 1 over 0.5, if you put in the calculator, 1 divided by 0.5 is 2. 1 over 0.2 is 5. 1 over 0 is undefined. And that's not imaginary, it's actually undefined. It's something entirely different. This is going to give us -5, -2, -1, and -1/2. So let's plug these guys in. So 3 is 1/3. At 2, we're at 1/2. At 1, we're at 1. That's one we definitely know. When x is 1/2, we're going to be at 2. And when x is 1/3, we're going to be at 3. So it looks kind of like that. And at 0, something weird's going to happen. And we could do the points on the other side. -1 is -1. -2 is 1/2. If we did 3, it would have been 1/3. -1/2 is 2. -1/3 is 3. And what these graphs look like is they look something like, they're going to be hard for me to draw. They look something like this. And like this. And what we have is we have over here a line that it gets close to, but it doesn't quite touch. So the purple line gets close to this, but doesn't quite touch. And we're going to call these dashed lines, we're going to call them asymptotes. So asymptotes are lines that the graph gets close to, but it doesn't quite touch. Okay, last two graphs. We have, this is an absolute value. What that means is anything, you take the value and you take the positive out. So -3, the absolute value of -3 is just 3. So this becomes 3, 2, 1, 0, 1, 2, 3. I was going to graph it. It looks something like this. And unlike a parabola, this one's not curvy. It's actually, it's a straight line, and then it does this quick turn and becomes a straight line again. That's our absolute value graph. The last one's y equal to x. They're just equal to each other. -1, 0, 1, 2, 3. And you should probably know what that looks like already. And that's just a line. And so those 6 graphs are going to be our base graphs, and we're going to be transforming those graphs.